Regulatory perspective in drilling focuses on a central point. Every drilling rig system has a technical purpose, but its broader value is in supporting well control, safety, well integrity, and compliance.
The focus is the drilling rig as an integrated safety system. Hoisting, rotary, circulation, and pressure control functions must work together to construct the well safely and manage operational risk.
The first system is hoisting. It includes the derrick, crown block, traveling block, drilling line, hook, and drawworks. Technically, this system raises and lowers drill pipe, casing, and downhole equipment. From a regulatory perspective, the issue is controlled movement of heavy loads.
Controlled movement is the key distinction.
Exactly. Regulators are concerned with dropped objects, load handling, equipment failure, and personnel exposure. Inspection, maintenance, load limits, and competent operation are not administrative details, they are safety requirements. The workover procedures reinforce this by emphasizing equipment limits, rig supervision, and safe execution of critical operations. The hoisting system must be treated as a safety critical function.
The rotary system then brings energy into the well construction process. It rotates the drill string and bit to cut through rock and create the well bore.
And that rotation creates a different regulatory concern.
Correct. The rotary system involve a rotary table and Kelly arrangement or a modern top drive. In both cases, rotating machinery must be properly guarded, maintained, and operated within approved engineering limits. The wider operational guidance also places importance on rig equipment specifications. That matters because regulatory assurance depends on knowing the limits of the equipment before operations approach those limits.
So the regulator is not only asking whether the bit turns,
Precisely. The regulator is asking whether the system turns safely, predictably, and within its designed operating envelope.
the circulation system is often the strongest link between engineering and well control. Mud pumps circulate drilling fluid down the drill string, through the bit, and back to surface through the annulus.
This is where drilling fluid becomes a barrier.
Yes, the drilling fluid transports cuttings, cools, and lubricates the bit, stabilizes the wellbore, and provides hydrostatic pressure to control formation fluids. The drilling engineering material places strong emphasis on fluid classification, properties, testing, formulation, calculations, and hydraulics. That aligns directly with regulatory thinking.
Because if fluid properties are not controlled, the first barrier against uncontrolled flow can be weakened.
Exactly. Regulatory requirements therefore focus on mud monitoring, fluid properties, containment, discharge control, and environmental management. The circulation system is not only about moving fluid, it is about maintaining wellbore stability and preventing escalation.
The pressure control system is the most critical system from a safety perspective. It includes the blowout preventer, or BOP, the choke manifold, accumulator system, and associated control equipment.
This is the last line of defense.
If formation pressure exceeds the hydrostatic pressure provided by drilling fluid, a kick can occur. The BOP system allows the well to be shut in and controlled before a kick becomes a blowout. The operational guidance supports that same regulatory priority through well control procedures, emergency response planning, communication requirements, disaster drills, and defined responsibilities for field and engineering personnel.
That connects the equipment to organizational readiness.
It does. Testing, maintenance, competency, emergency procedures, and regular well control drills are not separate from the pressure control system. They are part of the system's reliability.
The important regulatory message is that these four systems do not operate independently. Hoisting moves equipment, rotary drilling creates the well bore, circulation maintains stability, pressure control protects the well if conditions change. Together, they create multiple barriers. That is the foundation of well integrity management. Technical systems, competent execution, documented inspection, and readiness to respond.
The regulatory outcomes are clear: protect people, protect the environment, protect assets, support responsible resource use, and demonstrate compliance throughout drilling.
To conclude, the key message is that a drilling rig is not only a mechanical arrangement, its systems are safety barriers.
Well, integrity depends on those barriers working together, being maintained, being tested, and being operated within regulatory expectations.
The essential question for every system is therefore, does it perform its technical function while preserving control, safety, and compliance?